Hello everyone. So, hello everyone. This video we're going to be talking about exponential functions and integration. The exponential function and integration. Okay? And integration for exponential functions is a lot better than most other functions because the integral is very, very easy. Okay? And this is because since the derivative of e to the x equals e to the x, the antiderivative or the indefinite integral of e to the x with respect to x is also equal to e to the x plus c. Okay, can't forget plus c. So you can see that this lesson will be relatively easy because there is no difficulty in actually finding integrals. Okay? So there's not much difficulty for integration. Okay? So let's see what I mean. I want to do a couple of integrals. So let's look at the integral. Let's look at the integral of e to the 2x dx. Okay, so e to the 2x dx. So what can we do here? Now we know e to the x, the derivative of e to the x is e to the x. But we have a 2x here. So since the derivative of 2x is equal to 2, why not let u equal to 2x and perform a u-substitution? Okay? And you can introduce the 2 required over here by multiplying the integral by 1/2. Okay? So you introduce this 2, and now you have 1/2 e to the u du, which equals 1/2 e to the 2x plus c. 1/2 e to the 2x plus c. Okay, so this seems to be a good one. Okay, we've just saw that 1/2 that the integral of e to the 2x is 1/2 e to the 2x plus c. Okay, so let's look at the case of e to the kx. Okay, because with with exponential functions with base e, integrals are really easy. Okay, so let's see if we can generalize this. So e to the kx dx, where k is an integer other than 0. Okay, so k is an integer, k is not equal to 0. Now you can apply a u-substitution, but instead of letting u equals 2x, we let u equals kx. Okay, and the derivative of kx is k, so we need a k on the front. So we can do that by introducing 1 over k times k e to the kx dx. And this gets us 1 over k times e to the kx plus c. Because the integral is not that hard, you're allowed to make these generalizations. Okay, it's easy to make generalizations of such integrals, such as this. Now, not all integrals are this easy. Let's look to some more challenging ones. Okay, so let's look at the integral e to the square root of x over the square root of x dx. So this one's not super challenging in the fact that the derivative of square root, you know immediately what you should sub in for u. Okay, just u substitution, we can easily just make u root x. That means du dx is 1 over 2 root x. You already have a root x in a denominator, so what you can do is introduce the 1/2 by multiplying the integral by 2. And now you're golden for integrating it, okay? So you have 2 times e to the u du, which equals 2 times e to the root x plus c. See, not that difficult. Not that difficult. Now, what if I wanted to do this? The integral of ln of e to the 2x minus 1 dx. Now, we can't really integrate ln of x that easily. Okay, so rather than doing u substitution, what we can do is kind of cheat a little and use the properties of logarithms. So you don't actually do any e to the whatevers in this problem. Okay, since this just equals 1. And now this becomes a easy integral. Okay, so you have 2 x squared over 2 minus x, or x squared minus x plus c. Let's do another, okay? Because we can just keep on doing all these integrals, okay? So let's do a definite integral. Let's do a definite integral from 1 to 3 of e to the 3 over x over x squared. Okay? You can also write it like this. Okay, dx. Now, how would we do this? How would we approach this problem? Now, what is good to know is that your u is usually the exponent. So why not just let u equal 3 over x, or 3x to negative 1, and you get du dx equals negative 6 times x to the negative 2, or negative 6x over x squared. Now, we have an x squared in the denominator. Excuse me. We have an x squared in the denominator. So what we can do is introduce a negative 6 by multiplying by the integral by negative 1/6. So you have negative 6 e to the 3 over x over x squared dx. And now this becomes negative 1 over 6 times the integral from 1 to 3 of e to the u du. Now, you can change the limits of integration if you want, okay? So you can change the limits of integration. In fact, why don't we do just that, okay? So if u equals 3 over x, then we can change this to 1, okay? 3 divided by 3 is 1, and over here, we have 1 in the bottom, so that's 3. Okay? So we just changed it to corresponding u values, since this integral is a lot easier. Now, the upper limit is not supposed to be smaller than the lower limit, so we can invert the limits by taking the negative. Okay? Watch the video on definite integral properties if you don't know what I mean. Okay? So we inverted the limits, and now we can do an easy integral. Okay, so we have 1 over 6 times e to the u from 3 to 1. So that's 1 over 6 times e cubed minus e. Now, if we didn't change the limits of integration, you get negative 1/6 times the integral from e to u du, which equals negative 1/6 times e to the 3 over x from 3 to 1. And that gets us negative 1/6 times e minus e cubed, which can simply, if you know algebra, can be written as 1/6 times e cubed minus e. Okay? So it's no big deal. Okay, you can actually factor out an e to make it even more simplified looking. This is the value of your definite integral. Let's do one more. Okay? See, this integral is not hard. Okay? So what you can do right now is find a definite integral from 0 to pi over 2 of, this one's a hard one, not really. So e to the sine of pi x times cosine of pi x. Cosine of pi x dx. And we want to find this definite integral. So you have sine pi x and cosine pi x. So of course there'll be an easy u substitution with u equaling sine of pi x. That means du equals pi cosine of pi x dx. So this, we need a pi over here, so we can introduce a pi by multiplying by 1 over pi. Okay? And we have pi e to the sine pi x cosine pi x dx. Now using this, you can easily make a substitution. E to the u du. Okay? du is this quantity, and u is this quantity, so this turns into a much simpler integral. So 1 over pi times e to the sine pi x from pi over 2 to 0. Now, what do we do here? Well, in order to evaluate this, 1 over pi times e to the sine of pi times pi over 2. So pi squared over 2 minus, well, sine of 0 is 0. So e to the sine of 0 is 0. Okay, so if e to 0 is 1. This is our answer. Okay, so these integrals are not that challenging, okay? However, this integral is very important for you to memorize, okay? It's very useful in the coming lessons. Thanks for watching. If you have any questions, please comment, make sure you like and pass on this video. Thank you for watching.